back to my YouTube channel. So today we'll be talking about power. Ahem, I'm sick, so pardon me if I sound a bit hoarse. So power, yes. So the most simple equation that we know for power is P is equal to work divided by time. And we know that work is also equal to the change in energy. So we can also derive from this equation that P multiplied by T, we just move that over there, is equal to the change of energy, which is, we're going to assume the change of kinetic energy, because let's just say there's no potential energy, gravitational potential energy, is equal to mv squared over 2, which is mass v final squared divided by 2, minus mv initial squared divided by 2. Okay? Is a formula. Beautiful. And this formula is going to be used in a period, over a period. Let's just use a dot as a period of time. I will explain what I mean by that on the next step. The next equation is power is equal to force multiplied by velocity. So, yes. This, if you graph this, then it will look, I'm going to erase a little bit because it's kind of, so P is equal to FV. And if you graph this, you're going to get a graph that never reaches the X or the Y axis. And this equation works on a certain instant. Like, this is always true on a certain instant. For example, if I say at this point, P is equal to FV. At any certain point, P is equal to FV. But it does not work over a period of time. The other equation that I said is P multiplied by T is equal to change of energy. That works over a period of time. Okay? This does not work for a period of time because, fortunately for you guys, I don't know calculus. So, if you want to do this for a period of time, you're going to have to use calculus. We don't like that. So, the final equation that we're going to learn today is displacement. Displacement is used by X. X is equal to the square root of 8 multiplied by P, which is power, multiplied by time cubed, divided by 9 mass. 9 multiplied by mass. And then this equation looks very complicated, and it is pretty complicated, but that is derived from a bunch of weird mathy stuff that I don't want to talk about. And it uses calculus. So for now, since I'm a middle schooler, let's just use this and just memorize it, okay? So that just gets us right into those practice problems. So here's the practice problem, and I'm gonna read it off my computer. Okay, 2 kilogram object is at rest. A constant power of 16 watt is applied. How far has the object moved when its speed reaches 4 meters per second? And then there's the multiple choice, which is A, 1.33 meters, B, 2.67 meters, C, 4 meters, D, 8 meters. So it's pretty straightforward, but it's not really straightforward at the same time. You need to combine multiple equations for this. But if you think you got this, go ahead, pause the video and come back and listen to me yap. Great, since you guys are back now, we can yap. Ahem. So, no, we are trying to find distance or displacement because it says how far. So, first step, we're going to write down the complex equation for displacement. So, x is equal to the square root of 8 multiplied by p multiplied by t cubed divided by 9m. So we know p, which is 16, we know m, which is 2, but we don't know t. But lucky for you, we can use another equation. Pt is equal to the change of energy, which is equal to mv squared over 2 minus mvi squared over 2. And since it says this object starts at rest, the initial velocity is 0, so this entire thing is 0. So anything minus 0 is just itself. So we can just kill that. Now we have this equation. It is very sigma. But we do know the velocity and mass. So we know that m is 2 multiplied by 4 squared, which is 16, divided by 2. These 2 cancels, and we get 16. So Pt is equal to 16. And we also know that power is 16. So now we move 16 to the other side. T is equal to 1 second. Now, all we have to do is to plug the numbers that we have in this equation. So we get the square root of 8 multiplied by 16 multiplied by 1 cubed, which is just 1, divided by 9 multiplied by 2. So what we get after this equation is 8 over 3, because the top is 64 and then the bottom is 9, so the square root of that is going to be 8 over 3. And since the answer choices are in decimals, and in physics computation, you're not really allowed to use a calculator, we can approximate. So we know that 9 divided by 3 is 3, and we know that 6 divided by 3 is 2. So we know that this number is around 3 and 2, a little bit more towards 3. So, and the only answer here is 2.67. So the answer is B for this problem. Okay? It's a bit confusing because you have to take 2 equations together. But I believe in you. It's okay if you didn't get the first one. We still have 2 more problems left to redeem yourself. So let's see the next problem. This is the next problem, and now I'm going to read it off my computer. If the power delivered to a car is doubled while it is moving at a certain speed, what happens to the instantaneous force the engine exerts on the car at that moment? A, the force is halved. B, the force remains the same. C, the force is doubled. D, the force increases by a factor of 4. So, I read the question. You can now pause the video and come back to listen to my explanation to check your answers. Hi, now that you're back, let's talk about it. So, they ask if the power is doubled at moving at the same speed. So in this problem, it is asking for a certain instant. So since we know that this is happening in a certain quote-unquote instant, we can only use P is equal to FV. And then it asks when this V stays the same, what happens to the force? And this is a pretty straightforward question. If the P is doubled and V stays the same, then F is also going to be doubled. That 2 is so ugly. That F is also going to be doubled. And so the answer is C, because it says the force is doubled. Pretty straightforward. I hope you got that. Okay. Okay. Hi. I'm sorry that there was a little cut there, but there were some technical difficulties. So, anyways, last question. This is the problem, and I'm gonna read it. A car of a mass m is accelerated from rest by a constant power p. Which of the following correctly describes the relationship between the instantaneous speed v and the distance traveled x? And these are options. So, go ahead, pause the video, come back, listen to my beautiful explanation. Good, I didn't stain my shirt. Okay, I stopped with my left hand. Anyways, now since you're back, let's explain. So, clearly, we want the relationship between x and v. So, we're going to use our equation with x, which is 8 multiplied by pt cubed divided by 9m. And then we also want the equation with v. Okay. So, since this is over a period of time, we're gonna have to use the change of energy equation. So that is gonna be p multiplied by t is equal to half mvf squared minus half mvi squared. So since we know that this is from rest, this is completely and utterly useless. So we can just kill that. And keep it in mind, we are trying to find how is it v and x proportional, so we don't actually need to find a certain value. And so since we quote unquote know m and know p, we don't really have to care about this. We only care between the relationship between t and f. So we know that square root t is going to be equal to v. And I'm going to say this, I said it before and I'll say it again, it is not plus minus, because first of all, t is, whatever. So it's not plus minus, that's in math. And it does work sometimes in physics, but in this case, we don't need the plus minus. So anyways, now what we have to do, we just put this in here. So, and then now we're basically done. And so, we know that this is the relationship between t and v, but we want the relationship between x and v. And then we have this equation. So we can use our common sense and plug this in this equation. And now we have the relationship between x and v, which is v is proportional to x 1/3. And then the answer is D. Okay? So, I hope this makes sense. I hope I explained properly. And anyways, thank you guys for listening. And have a wonderful day. Bye.